Welcome to Analytical Chemistry Vision, a platform dedicated to exploring the theoretical and experimental aspects of chemistry, blending classroom learning with laboratory research to enhance understanding and inspire innovation in chemical science. This lecture on Statistics in Chemical Analysis, Part 3 of Analytical Chemistry, introduces key statistical tools: mean, median, average deviation, standard deviation, relative standard deviation, F-test, and student's t-test. Designed for UG, PG, and research students, it emphasizes the inclusion of these statistical parameters in research work to enhance data quality, accuracy, and reliability, ensuring meaningful interpretation and scientifically sound analytical results. In this third part of the Analytical Chemistry Statistics section consists of: first one is mean and median. Second one is average deviation. Third one is standard deviation. Fourth one is relative standard deviation or coefficient of variation. Fifth one is test of significance, where we learn F-test and student t-test. Sixth is linear regression line or linear least square. Seventh is correlation coefficient. Finally, we will solve the numerical problems based on our learnings on these topics. Why we learn statistics? To understand the significance of the data that is collected during the experiments. First, we will learn mean, or x-bar, which is a measure of central tendency that represents the average value of a set of numbers. It is calculated by summation of all the values xi in a data set and then dividing by the total number of values. 12 gram, 11 gram, 14 gram, and 13 gram of iron in soil. What is mean value? Mean bar equal to 12 plus 11 plus 14 plus 13 plus divided by 4, which is equal to 12.5 gram. Median is the middle value of a data set when all the numbers are arranged in ascending or descending order. Steps: arrange the data in order. If the number of observations, n, is odd, the median is the middle value. If n is even, the median is the average of the two middle values. Examples: for values 3, 5 and 7, the median will be 5. For values 4, 6, 8, 10, median will be equals 6 plus 8 divided by 2 is equal to 7. Another, the use of average deviation in chemical analyses. Average deviation, AD, is also called as a mean deviation, which is the average of the absolute differences between each observation, xi, and the mean of the data set. Formula for determination of AD is equal to summation of xi minus x bar divided by number of observation, and it shows how much, on average, the data values deviate or differ from the central value. Where xi is individual measurements, x bar is mean value, n is number of observations. Here, we will see some numerical problems to understand how to calculate the value of average deviation, AD, and to know its significance in chemical measurement. Question 1. The copper levels in 5 water samples showed the value of 2, 4, 6, 8, and 10 microgram. Calculate the average deviation. By putting the values into the equation of average deviation, as shown here, we can calculate the value of AD to be 2.5 micrograms per liter of copper in the water sample. This demonstrates how AD helps in understanding the consistency and reliability of chemical measurements. Next, we will see the standard deviation. Standard deviation, SD, is a measure of data dispersion that shows how much individual values xi differ from the mean x bar. The equation is square root and summation of xi minus x bar to power 2 divided by n minus 1. Where xi is individual measurements, x bar is mean value, n is number of observations. Similarly, relative standard deviation or coefficient of variation is determined, which is equal to SD by mean value in multiply with 100%. The formula given here, relative standard deviation percentage, RSD, is a key parameter to evaluate precision in chemical analysis. It expresses the variability of replicate measurements as a percentage of the mean. A low RSD percentage signifies good precision, consistent data, and reliable analytical performance, essential for quality assurance and method validation. Here, now we will understand the precision or reproducibility by taking the example of this numerical problem. Question 2. The following replicate weighing were obtained: 29.8, 30.2, 28.6 and 29.7 milligrams. Calculate standard deviation, mean and RSD, percentage. Solution is given below. For solving the question related to SD and RSD, we have to draw 3 columns and rows based on the measured values, xi, and at the end the mean value x bar is calculated, which is found to be 29.6. And then in the second column, the difference between each measured value with mean value is calculated. For example, 29.8 is xi value is minus with 29.6, mean value in the answer is 0.2. Similarly, other values such as 0.6, 1.0 and 0.1 is calculated. After last column will be square of the xi minus an x bar value for each measurement, and finally the values summed, the value obtained is 1.41. Here, we will put the value of 1.41 in the equation of standard deviation. In the denominator, the number observation is 4 minus 1 will be equal to 3. Which further solving it becomes square root of 0.47, and finally the value of SD will be 0.69. From the value of standard deviation we can determine the RSD percentage by putting values in the equation of RSD, given here, which is equal to 0.69 divided by 29.6, mean value and multiply by 100%. Finally the RSD percentage is 2.3%. Thus, 2.3% RSD indicates good precision in the analysis, showing consistent and reliable measurements with minimal variability, ensuring accuracy and reproducibility of results. Let us learn another interesting topic in statistics, that is test of significance. The test of significance in analytical methods is a vital statistical approach used to evaluate whether differences in analytical results are genuine or caused by random experimental error. It helps determine the accuracy, precision, and reliability of analytical procedures. By applying tests such as the F-test for comparing variances and the student's T-test for comparing means, analysts can assess the performance of instruments and methods. These tests ensure that analytical data are scientifically valid, reproducible, and trustworthy, providing confidence in experimental results and supporting sound scientific decision-making. Before F-test, we will understand what is new or test method or your method. What is standard method? Suppose you have developed new method for determination of iron in water sample using colorimetry. This will called as a new method or test method or your method. When atomic absorption spectrometry (AAS) is used to validate the result of colorimetry, it is called as a standard method or reference method. So first test of significance is F-test. It is the ratio of the squares of the standard deviations of two analytical methods. The square of the standard deviation is called variance. Here, S is the standard deviation of the first, new or developed, method being tested for chemical measurement, and S is the standard deviation of the standard or reference method used to check the variability of the first method. After finding the calculated F value from two analytical methods, then the value is compared from the tabulated value, which is standard value, given in Table 1. If the calculated F value exceeds tabulated F value at the selected confidence level, V1 or V2, then there is a significant difference between the variance of the two methods. It determines whether the observed difference in variability between methods is statistically significant or due to random error. This test ensures that analytical results are consistent, reproducible, and reliable. Let us understand here how to calculate F value from this given numerical problem. In addition to know whether your new method developed or tested is reliable for chemical analysis or showing no statistically with standard method. Furthermore, this type of test can be also include research work related to chemical analysis for reliability. Please see here the question Note 3. You have developed a new spectrophotometric procedure for determination of glucose content in blood. You have chosen the standard method Folin-Wu procedure with which to compare your results. Your tested new method proved the concentration of glucose in blood is 127, 125, 123, 130, 131, 126, and 129 milligrams. However, the standard Folin-Wu method provided 130, 128, 131, 129, 127, and 125 milligrams. From the following two sets of replicate analyses on the sample, determine whether the variance of your method differs significantly from that of the standard method. This type of question can be asked for F-test. Let's see here how we can solve this type of question. As we know that f is equal to the ratio of square of the S1 and S2, where S1 is standard deviation of your tested method and S2 is Follin-Wu or standard method, where square of standard deviation become the summation of xi minus x bar to power 2 divided by n minus 1, where n is number of observation. For the calculation of f-test in simple way, fist the results for glucose in blood, that is your method or newly developed method is arranged in first column as a xi1 value is 127, 125, 123, 130, 131, 126, and 129 milligrams, L, their mean value, x bar 1 is 127. And next second column will be the difference of xi1 and x8 bar, the values calculated will be 0, minus 2, minus 4, 3, 4, minus 1 and 2. And third column will be the square of difference of xi1 and x1 bar, and values will be 0, 4, 16, 9, 16, 1 and 4 and their summation will be 50, which is square of standard deviation. Similarly, the results of Follin-Wu standard method is placed in fourth column as xi2, such as 130, 128, 131, 129, 127, and 125 milligrams, L and their x bar 2 value will be 128. Fifth column shows the difference of xi2 minus x bar 2, mean, and the values are 2, 0, 3, 1, minus 1, and minus 3, and the sixth column is summation of square of the xi2 minus x bar 2 will be 4, 0, 9, 1, 1, and 9 and their summed value will be 24. Here, we will put the values for your method, which is the difference of xi1 minus x bar 1, whole to the power 2 divided by n minus 1, which is equal to 50 divided 7 minus 1. Which further solved, it become 8.3, this obtained value will be square of S1. Similarly, for standard method, which is the difference of xi2 minus x bar 2, whole to the power 2 divided by n minus 1, which is 24 divided 6 minus 1. Which further solved, it become 4.8, this obtained value will be square of S2. And finally, the value of f will be 8.3 divided by 4.8 will be 1.7. Next, we will compare the f calculated value 1.7 with tabulated value given in given table. The tabulated value f at 95% confidence level when V1 at 6 and V at 5 is 4.95. Thus, based on calculated f value is less than tabulated value, and then we can say that there is no significant difference in the precision of the two methods. Overall, the conclusion the calculated f value 1.7 is found to be lower than the tabulated f value 4.95 at the 95% confidence level, indicating that there is no significant difference in the variances of the two analytical methods. This means the precision of the newly developed spectrophotometric method for glucose determination is statistically similar to that of the standard Follin-Wu method, demonstrating that the new method is reliable, consistent, and can be confidently used for routine chemical analysis. Let us see student t-test, which another most important topic in statistical analysis of chemical measurements. In this test, comparison is made between two sets of replicate measurements made by two different methods. One of them will be the test or your method and other will be an accepted or standard method, like we have seen for f-test. A statistical t-value is calculated and compared with a tabulated t-value for the given number of tests at the desired confidence level. If the calculated t-value exceeds the tabulated t-value, then there is a significant difference between the results by the two methods at that confidence level. If it does not exceed the tabulated value, then we can predict that there is no significant difference between the methods. Student t-test is of two types. First one is t-test when an accepted value is known. Second one is student t-test when comparison of the two mean of two samples. Let us see here, t-test when an accepted value is known. The formula for calculation is plus minus t is equal to x bar minus mu, multiplied by square root of n, divided by SD where t is statistical value, x bar is average mean value, n number of observations and SD is standard deviation and mu is true mean value. Next we will student t-test when comparison of the two mean of two samples. The formula for student t-test when two mean of samples is compared is plus minus t is equal to x bar 1 minus x bar 2 divided by SP, where SP is pooled standard deviation and multiply with square root of n1 into n2 divided by n1 plus n2. Further, SP is calculated based on the formula equal to square root and the summation of xi1 minus x bar 1 whole to the power 2, and again, plus summation of xi2 minus x bar 2 whole to the power 2, and so on, plus the summation of xik minus x bar k to power 2. All is divided by n minus k, where xi1 and xi2 are the means of each case sets of analysis and xi1, xi2, and xik are the individual values. N is total number of measurement and equal to n1 plus n2 plus n3 and nk. Let us see here numerical problem. Question number 5 on student t-test when comparison of the two mean of two samples. A new gravimetric method is developed for iron 3, in which the iron is precipitated in crystalline form with an organoboron in KH compound. The accuracy of the method is checked by analyzing the iron in an ore sample in company with the results using standard precipitation with ammonia and weighing of Fe2O3. The results reported as pratishat for each analysis is follows. The concentration of iron found by your test method is 20.10, 20.50, 18.65, 19.25, 19.40, 19.99, and the standard method give the result of 18.89, 19.20, 19.00, 19.70, 19.40. Then question is there a significant difference between two methods? For calculation of t value in the student test, F test is first performed. For this, F value is calculated based on the formula F equal to ratio of square of S1 and S2. S1 square is individually calculated using the given formula, which is equal to summation of xi1 minus x1 bar whole to the power 2, divided by n1 minus 1. Similarly, S2 square is calculated, which is equal to summation of xi2 minus x bar 2 whole to the power 2, divided by n2 minus 1, and this value is calculated similarly as previously calculated. xi1 will be the values from your test method, given in first column, and their x bar 1 will be 19.65, followed by the difference value of xi1 minus an x bar 1, in second column, and third column shows the square of the difference of xi1 minus an x bar 1, and their summation is 2.262, shown in third column. Similarly, xi2 from standard method is given fourth column, and x bar 2 is 19.24. Likewise, the square of the difference of xi2 minus an x bar 2 is calculated, given in sixth column, and summed value is 0.420. Here, summed value of xi1 minus x1 bar whole to the power 2, divided by n1 minus 1 is put into the formula, which will be 2.262 divided by 6, which is number observation for first method, minus 1, which further solving it becomes 0.452. Similarly, sum value of xi2 minus x2 bars whole to the power 2, divided by n2 minus 2 is put into the formula, which will be 0.420 divided by 5, which is number observation for second method, minus 1, which further solving it becomes 0.105. Finally, putting the value of S1 square and S2 square, F equal to 0.452 divided by 0.105 will be 4.31. Further, the degree of freedom, V1 for test method is 5 and V2 for standard method is 4, and based on this F tabulated value in table is 6.26 at 95% confidence level, a 0.05 probability, shown in yellow colored. This means F calculated 4.31 is less than F tabulated value. Thus the two methods have comparable STD. DEV, S, and t-test can be applied. And next we'll perform the t-test. Here, the first formula for calculation of t-test and second one for calculation of pooled standard deviation. 2.262 is summed value for square of the difference of xi1 minus x bar 1, and 0.420 is summed value for square of the difference of xi2 minus x bar 2, which is divided by 6, number of observation for test method, and then plus with 5, which is number of observation for standard method, and minus 2. Finally, the calculated pooled standard deviation is 0.546. Now the putting the value in t-test, which is plus minus t is equal to x bar 1 minus x bar 2 divided by SP, where SP is standard pooled deviation, and multiply with square root of n1 into n2 divided by n1 plus n2. The calculated t value is plus minus is equal to 1.2. Finally, in conclusion, The tabulated t-value for 9 degree of freedom, 6 plus 5 minus 2, at the 95% confidence level is 2.262. The thus calculated value is less than tabulated value and thus there is no statistical difference in the results by two methods. Another most interesting topic in chemical measurement is linear regression line or linear least square. In chemical analysis, linear regression line or linear least square is a statistical method used to determine the best fit straight line through a set of experimental data points. It minimizes the sum of the squares of the vertical deviations, errors, between observed values and predicted values. This technique is commonly used in calibration curve preparation, where the relationship between instrumental response, y, and analyte concentration, x, is expressed as a linear equation, y is equal to mx plus c, where m is slope and c is intercept. Let us see the figure 1, standard calibration curve drawn between concentration and absorbance in coulometry or UV, visible spectrophotometry, or atomic absorption spectrometry. The linear regression line will be y equal to mx plus c, where m can be m into summation of xy minus summation of x, which multiplied with summation of y, and whole divided by n into summation of x square minus summation of x to the power 2. Further c, intercept can be summation of y minus m into summation of x divided by n, where n is number of observations. Here we will understand how the concentration of unknown substance can be determined using linear regression line of linear least square equation, y equal to mx plus c. Let us see the question 6. The standard concentration of iron, X, such as 2, 4, 6, 8, 10 mg, L give the absorbance, y, value of 0.85, 0.171, 0.255, 0.342, and 0.427, respectively by colorimetry or UV visible spectrophotometry. The absorbance of unknown water sample is 0.290. Determine the concentration of iron in given sample. Solution for this question. First, make two-column table given here. The concentration of iron, X, is put into the first column, and in second column, the respective absorbance value is put. First step is, compute the sums of given parameters. Here, number of observations, n is 5, summation of x values will be 30. Summation of y values will be 1.28. Next, each x and y values are multiplied separately and their sum is 9.39. Finally, each x values are squared and their sum is 220. The slope is calculated using the equation m equals n summation of xy minus summation of x into summation of y divided by n into summation of x square minus summation of x to the power 2. Substituting the values from the previous screen, m is equal to 5 into 9.39 minus 30 into 1.28 divided by 5 into 220 minus 30 to power 2. Further solving, m will be equal to 46.95 minus 38.4 divided by 1100 minus 900, which again equal to 8.55 divided by 200, and finally the value of m will be 0.04275. Hence, the slope, m, is 0.04275. Next, step 3 used for calculation of intercept, c is equal to summation of y minus m into summation of x divided by n. Substituting the values, c is equal to 1.28 minus 0.04275 into 30 divided by 5, which further solving, c will be 1.28 minus 1.2825 divided by 5 will be minus 0.0005, and hence intercept c will be minus 0.0005. Next, fourth step is to construct the linear regression line or linear least square equation or calibration equation, as we know that y is equal to m, x, plus c. Putting the value of m and c into the equation, which become y is equal to 0.04275x minus 0.0005. Further, calibration curve can be also drawn manually by taking graph paper between concentration and absorbance value is shown in figure 2. Also, this curve be also drawn using Excel using computer. In fifth step, we will use this calibration curve to determine concentration, x, of unknown sample by putting the value of absorbance 0.290. Where x become y minus c divided by m, and further solving 0.290 minus 0.0005 divided by 0.04275, and finally the answer will be 6.795 milligrams, with the concentration of iron found in water samples. In summary, this regression line can be used to determination concentration of unknown substance using any analytical instruments. Next important topic is correlation coefficient. The correlation coefficient, R, is a statistical measure that indicates the strength and direction of a linear relationship between two variables, typically, the analyte concentration, X, and the instrument response, Y, in chemical analysis. R is equal to n into summation of xy minus multiplication of summation of x and summation of y in whole divided by square root bracket n into summation of x square minus summation of x square and bracket close, into bracket n into summation of y square minus summation of y square and bracket close, where n is number of observation and x and y is measured points. Let us understand the usefulness of correlation coefficient equation by solving this numerical problem. 7 number. The standard concentration of iron, X, such as 2, 4, 6, 8, 10 milligrams, L give the absorbance, Y, value is 0.085, 0.171, 0.255, 0.342, and 0.427, respectively using colorimetry or UV visible spectrophotometry. Calculate the correlation coefficient, R. For this, draw two columns and put the absorbance and concentration in separate column as shown in the table. First step is, compute the sums of given parameters. Here, number of observations, n is 5, summation of x values will be 30. Summation of y values will be 1.28. Next, each x and y values are multiplied separately and their sum is 9.39, then, each x values are squared and their sum is 220. Finally, each y values are squared and their sum is 0.40078. Second step is, to put the obtained values from previous screen into the correlation coefficient. Our equation give here, where n is 5, summation of x, y, is 9.39 minus summation of x is 30 and summation of y is 1.28. Divided by square root, bracket n is 5, summation of x square is 220 minus summation x square is 30 to paper 2, bracket off. And again n is 5, summation of y square is 0.0400784 minus summations of y square is 1.28. This further solving, finally we will obtain the value of R as 1. This means the correlation coefficient of regression line is 1, which is very excellent, given in the figure 3, which is prepared using Excel. Please see here some short answer type question. Can give the answer of these questions? Further, also see here some long type question. In addition, some numerical problems. Can we solve it? Finally, in summary, the understanding this topic and use of different statistical parameters such as mean, median, average deviation, standard deviation, relative standard deviation, and significance tests, F-test and T-test, is essential for UG, PG, and research students. These concepts ensure accuracy, precision, and reliability in chemical analysis. They help evaluate data quality, validate experimental results, minimize errors, and strengthen analytical interpretation in research and applied scientific studies. Thank you for watching the Analytical Chemistry Vision. If you've not seen part 1 and part 2, please see to understand what is qualitative and quantitative analysis, classification of analytical methods, types of error that affect the chemical measurement in laboratory. If you like this video, please visit our channel for more interesting theoretical and experimental lectures. Don't forget to like, share, and subscribe, and share your feedback in the comments to help us improve further. Thank you.